Hey guys, in this lesson I want to go ahead and talk about how to take a complex number and write it as a trigonometric form. Okay, because that way it'll help us as we move along to be able to do what we call powers and roots of complex numbers. So just a couple of things just to kind of give you a foundation for this. So we talked about having the real axis and the imaginary axis, and then our A is our real part of the complex number. Our B is our imaginary, and then when we find out, we can make a triangle, and we can use the Pythagorean theorem to figure out this R value here, which is essentially the hypotenuse. Now, when we're talking about a complex number, remember that in trigonometry we no longer use x and y per se, but we use sine and cosine. Well, if I take this point here, and this is the angle theta, okay, and I want to find the component here with respect to a, so we're going to use sine. Sine theta is the opposite over the hypotenuse. Okay, so it would be b over r. So now this value of b, this component of b, it gives you a value of r times sine of that angle, theta. Likewise, with cosine is adjacent over the hypotenuse, which gives you a over r, which is now a, the component a is equal to r cosine theta. Well, if you remember that a complex number is a plus bi, then we get this value here, r cosine theta plus r sine theta times the imaginary part. Okay, so this gives us a way of rewriting a complex number into trigonometric form. So this is what we're going to be using. So that's what we're going to be doing. We're going to be taking this guy, rewriting it into this form. Now there's two things. One, you're going to have to find the r value, which is the hypotenuse. And that's not very difficult at all because you're using the Pythagorean theorem. The other thing though is you're going to have to use theta. Okay, you're going to have to find this angle theta. And how do you find theta? Well, if I wanted to find theta, I only had these two values, okay, available. Well, what trig ratio would I use? You would use tangent because you get the opposite and the adjacent. That's what they're going to be giving you. So that's what you're going to be using. You're going to find, in order to find this angle theta, you're going to use tangent of theta. And actually, you're going to end up using tangent inverse, and you divide b over a to figure out that angle. Okay, now one thing you have to remember is that when we talk about theta, the angle is measured counterclockwise. Okay, just like we do in geometry, right? It opens this way, this way. Okay, so you're gonna have to figure out this angle, and depending on where the point is located is gonna give you that angle. All right, so let's go ahead and see if we can do some examples here. It says write the complex number z, and this is a complex number in trig form. Okay, so the first thing we want to do is find the r value, and that's pretty easy because all we got to do is take the square root of a squared plus b squared. Remember, this is your a, that's your b. Don't include the I. So what do? A squared plus b squared, so that gives you 4. Negative 2 squared is positive 4. Square root to the square power, that means this cancels out. The square root cancels out, you're left with 3. This gives you 16, okay? And the r value is 4. Okay, that distance is 4. Great. So now that we have that, okay, we've gotten this part. Now I need to find cosine. I need theta. Okay, so now I take tangent inverse of my b value over my a value. Okay, so when I do that and I simplify, I get tangent inverse of square root of 3. In this case, it actually comes up pretty nicely because you can actually figure it out. When is tangent square root of 3? Well, if you think about tangent is sine over cosine. This is your sine. Okay, square root of 3 over square root of 1, square root of 3 over square root of 1 would give you that square root of 3. What angle am I folding? I'm folding 60 degrees, which is pi over 3. And you would think, oh, well, that's the answer. Well, yes and no. Now, you have to remember, where is this angle located? Now, if I graphed it, and you guys already know how to graph it, you would go negative 2 to the left on the real axis, and then you would go downward negative 2 square root of 3 units, which is maybe somewhere in between here, right? Well, if you notice, the complex number, the point is here on in the third quadrant. You have to figure out this angle here, right here in red. Okay, that's not pi over 3. Pi over 3 is actually over here. Okay, this guy is pi over 3. Well, how do you figure out this guy? Okay, how do you figure that guy out? Well, you would go ahead and add 3 plus 1 would actually be 4 pi over 3. Okay, 4 pi over 3. And that's how you would do it. Another way you can think about it is if you take this whole thing all the way over here and subtract this little portion, you would end up with 4 pi over 3. Okay, but for us here, I think this is probably the easiest way to look at it. We want to know this angle, right? We said, oh, we got the answer is pi over 3. Yeah, but it's actually on this side. So what we do is pi over 3, we add all the way another 180 degrees, and we end up with 4 pi over 3. So if I wanted to write the trig form for this guy, it would be z equals, what's my r value? 4. What's the cosine of the angle? 4 pi over 3 plus, then you would do I sine of 4 pi over 3. And that is the trigonometric form for this angle. Okay. Now, let's go ahead and do some examples and see what we can do here. Some of them will not be exactly pi over 3 that we can figure out, but it's okay. All right. So we got the complex number. We want to go ahead and figure out. We want to write it in trig form. So first thing, I need my r value. So the r value, remember, is the square root of a squared, which is 4 squared, plus negative 2 squared. Okay, good. So now if we square that, so we're going to get 4 squared is 16. 16 plus 4, square root of 20. That's my r value. Great. I'm done. Now I need to figure out the angle, because remember, okay, it's the cosine theta and sine theta. So I need tangent inverse of b over a. And this is pretty simple because they already give it to me straightforward. Negative 2 is my b. And then a is just the 4. Okay, so this ends up being tangent inverse of negative 1/2. Well, there's no way that I can do it with my mnemonic of the hand. So what do I have to do? I'm going to have to use my calculator. And when you plug it in, okay, you're going to end up with theta is approximately negative 26.56 degrees. And I had to use just degrees just because it would be something that you're used to seeing in degrees. Now, depends on what your professor wants you to do, degrees or radians, but degrees is perfectly acceptable. So this is negative 26.56 degrees, but we have to figure out, remember, where is the point located? So 4 minus 2i, right? So 4, that'll be over here. 1, 2, 3, 4, and then down 2. So this guy is located over here in the fourth quadrant. Remember, you have to figure out this angle going this way over here, how much it opens. Does that make sense? Well, how do I figure that out? Well, this negative 26.56, that's just this angle right here. Okay, that's this angle right here. Well, so how do I figure out this opening? You're going to take the whole thing. Excuse me. You can take the whole thing and you're going to subtract this little portion here, right? Because this negative 26 represents this guy right here. So you're going to subtract 26.56 degrees. And that's going to give me the remainder right here. And that's going to give you theta is approximately, what is that? Let me do it on my calculator real quick. Thought I had it. But that's all you would do. You don't need to go ahead and do anything more. But you do have to understand where that angle is located. Okay, so that gives me 333.44 degrees. So in writing this complex number, so you would write z is equal to square root of 20 times cosine of 333 degrees, 0.44, plus I sine of 333.44 degrees. And that's it. So you've just written this complex number in trigonometric form. And that's it. So let's go ahead and see. Hopefully this one is a little bit neater, even though it has a radical in it. So what's the first thing? I need my r value. Okay, what's the r? Well, you're going to take the square root, right? Take the square root of a squared plus b squared negative 2 radical 5. You notice that I'm always using plus, and that negative gets tucked inside the parentheses. So that's going to give you 2 squared is easy. That gives us 4. Okay. Now, negative 2 squared, that's 4. Then the square root and the square simplify out, so you're just left with 5. So 4 times 5 is 20. So we're left with the square root of 24. Nice. Easy. I'm not going to go ahead and simplify. I'm just going to leave it there. I know you can probably simplify this further, but it's okay. And I think your professor will allow you to leave it like that. Now I got to figure out my angle. Tangent inverse of b over a. Well, what's your b? Negative 2 radical 5 over positive 2. And then you see that it simplifies out. So that's going to give you tangent inverse of negative radical 5. Again, there's no way I can use it with my hand mnemonic, and that's okay. So this ends up being theta is approximately negative 65.91 degrees. Okay, so now I got to figure out where is this angle located. Now remember, this is 2 minus 2 radical 5i. So if I were to draw that, that would be here. Let's see, 2 to the right, and then down 2 here. Right, somewhere over here, right? Again, it's in the in the fourth quadrant. So I have to go all the way around. I have to figure out what that degree is. It's got to be over 270 degrees for sure. Okay, so where's that negative 65.91? It's this opening here. It's this opening here. So what I'm going to go ahead and do is I'm going to take 360 degrees minus 65.91. And that's going to give me 294.09 degrees. Good. So my trig form of this complex number is square root of 24. Okay. Cosine of 294 degrees, 0.09. Okay. Plus, I put the I in the front. It depends on how your professor wants to do it, but I don't think it doesn't really matter. Sine of 294.09 degrees. Okay, and that's it. So I think the biggest thing is recognizing where this point or complex number is located and making sure you're finding the counterclockwise angle. All right, let's go ahead and do 2 more, guys. How about this guy? This one's a little bit tricky if you think about it. So remember, 3i, well, where's the real part? This is the same thing as writing 0 plus 3i. So let's go find the real part, the r part, and that's the square root, okay, of a squared plus 3 squared, and you're going to end up with 3, okay? And you guys can see that, pretty simple. Now I need to find the angle, right? Tangent inverse of b over a. What's b? It's 3. What's a? There's nothing. Well, wait a minute, I can't do that, right? It's undefined. Well, that doesn't help me out any much, really, right? So let's go ahead and graph and see what that tells us. Well, where is 0 plus 3i? Well, 3i, you're not moving anywhere left or right on the real axis, but you are moving up 3 units over here. That's the location of 3i. So if you think about it, if you open it up this way, well, what's that angle? Well, that's 90 degrees. That's pi over 2. Okay, so theta is actually pi over 2. And you see how I had to do that? I had to see the visual of the angle in order to determine the angle for this guy. So now I can go ahead and write it. Z is going to equal to 3. That's my R value. Cosine of pi over 2 plus sine of pi over 2 I. And this time I decided to put the I on the back. Okay, great. Last one, guys. Let's go ahead and distribute this guy. Okay, distribute that guy. It looks kind of weird. Negative 3 plus 3 radical 2I. Okay, now I can go ahead and solve it. Let's go ahead and find the R value. All right, it's a square root. Negative 3 squared plus, and then we have 3 radical 2 squared. All right, let's go ahead and do the math. Negative 3 squared, that's pretty simple. That's going to give me a 9. And then that's plus 3 squared is 9 times, then the radical simplifies out, so you're left with just a 2. So we got 18 plus 9, that's 27. And I can go ahead and simplify that, but I'm just going to go ahead and leave it like that. So now we have that, right? Now I got to figure out my angle. So tangent inverse of b over a. What's my b value? Well, remember I distributed this guy, so now this is what I have here. So my b value is 3 radical 2 over negative 3. All right. Well, if I go ahead and simplify it, I end up with tangent inverse of negative radical 2. Again, I can't go ahead and solve it using my mnemonic with my hands, so I have to go ahead and use my calculator. So I end up with theta is approximately, now this is the answer I get on the calculator. I get negative 54.77, I'll just go 74 degrees. But again, you have to go, let's go ahead and look at where this guy is located. Okay, so if I go ahead and graph negative 3 and positive 3 radicals, so if I go negative 3 here and I go up, I'm going to end up somewhere up here, right? So I have this guy here. Okay, so I need to figure out this opening here. But wait a minute, what's this negative 54 degrees? Actually, it's actually talking about this guy right here. Okay, that's what this guy's talking about. 54 degrees. Okay, that's what this guy's talking about. Now the negative comes from the position. You notice that this guy is this way. Okay, and then this guy is up. That's why we have that negative. But in essence, the 54 degrees, it represents this angle here. Well, how do I figure out this opening here? Well, think about it. If you take 180 degrees and subtract this guy, you end up with the angle that you're looking for. So if you take 180 degrees minus the 54.74, and that's going to give you 125.26 degrees. Great. So that's the opening of this guy. So having a visual really helps you understand what the theta should be. So let's go ahead and write it. Z is equal to my R value, which is radical 27. All right. Cosine of theta, which is 125.26 degrees, plus sine of 125.26 degrees, I. And there it is. So hopefully that helps, guys. Good luck to you guys. Hope you guys are working hard. Keep it up. Until next time.